Welcome, this is the 2.1 Ready Set Go homework solutions for the IM1 honors class. Alright, we have here, ready? It asks us to find the next term, the next two terms. For negative 20, 100, and negative 500. I have to determine if there's a common difference or a common ratio. Here I saw that the common ratio is negative 5. Negative 20 divided by 4 is negative 5. Right? So I can apply that. Okay, so to get the next term, negative 500 times negative 5, right? This should get me a value. Then the next one after that, I multiply that by 25 because that is negative 5 times negative 5 is 25. Okay, so it should become 4, negative 20, 100, negative 500, 250, and 12,500. Alright, those should be your next two terms. You're applying the common ratio again. Alright, next we have 2. 3, 5, 8, 12. I saw I cannot find a common difference. Okay, and I cannot find a common ratio. So it is neither arithmetic or geometric. Therefore, I can't find the next two term. This is quadratic. There is a way to do this, but you're going to see that in high school. 3. 63, 48, 36, 27. I see the numbers going down. I found the common ratio is 0.75 or 3 over 4. Doing that work, to do that, I did 48 divided by 63. I saw that gets me a fraction of 3 over 4, or in decimal version, it is 0.75. So I can just apply that. Okay, 27 times 3 over 4 gets me 20.65. If I multiply 20.65 times 3.4, if I apply 20.65 times 0.75, it gets me 15.1875. Next, we have 4. The common difference here is negative 0.75. It is going down by that common difference. How did I do that? I showed the work here. 0.75 subtract 1.5 gets me negative 0.75. Okay. Right. The next two terms, if I just apply that, it is negative 1.5 and negative 2.25. 5. 4, 10, 5 over 2, 5 over 8. Common ratio is 1/4 because it is decreasing rapidly. Okay. The work, 10 divided by 4, just becomes 1/4. I think that's also 0.25. Okay. I could write that as if you like, or applying that 4, 10, 5 over 2, 5 over 8. Apply that again, 5 over 32, then 5 over 28. Next, 1, 11, 111, 1111. No common ratio nor common difference. 7. Okay, common ratio was 1.5 or 3 over 2. Here's the work. I did negative 5.4 divided by negative 3.6. I saw that it is 3 over 2. Apply the common ratio to get the next terms. Here's the sequence. Found that the common difference was 17. Here's the work. Negative 47 subtract parentheses negative 64 gets me my 17. Okay? Do you see how it's increasing? That's why the common difference is a positive number, right? Applying the common difference gets me the next two terms. It is increasing because the common difference is positive. Next, you create a predictable sequence of at least 4 numbers that is not arithmetic or geometric. I made the Fibonacci sequence. 1, 1, then becomes 2, becomes 3, right? 3 is a sum of 2 and 1. 5 is a sum of 3 and 2. 8 is a sum of 5 and 3. 13 is a sum of 8 and 5, right? The next term is always a sum of the last two terms, which is called the Fibonacci sequence. Alright, we should have now the set part. The set part, it asks you to find if it's discrete or continuous, given a scenario. So I just want to review a couple things with you. Understand that to find a discrete or continuous, you're only looking at the domain. Okay, the independent variable or the input. In this case, a discrete is when you only have integers like 1, 2, 3, 4, 5. It's finite. Okay, finite. Okay, the continuous is you could have all possible numbers. So you could have fractions, right? You could have irrational numbers. So you could have like 1, you could have 1.5, you could have 2, you could have 2.3, 2.1, 2.3, you could have 3, 3.145, right? You could even have pi, right? You could have the constant of e, right? Any number here, okay? All right, so let's test that out. Look, you're always looking at the domain. Number one, the hair on your hair grows 1/2 inch per month. So the domain here is month because it depends on the month. Okay, so can month be continuous or discrete? Okay, we say it's continuous because your hair can grow at 0.5 months and 0.125 months. Okay, right? You can have decimal versions of months. Okay, your hair is still growing. Next, for every single ton of paper that is recycled, 17 is saved. The domain here is tons of paper because again, the trees depend on the tons of papers that is being saved. We say this is discrete because there is a finite number of paper that is recycled. You can't have 0.5 tons or 0.125 tons of paper. Okay. Next, 12. Approximately 3.24 billion gallons of water flows over Niagara Falls daily. The domain is days. Okay. Continuous because the water can flow at 0.5 days and 0.125 days. Okay, the water still flows. So this is a continuous thing on those days. Next, the average person laughs 15 times per day. The domain here is days because again, the laugh depends on the day. Okay, so we would say continuous because you can laugh on days on 0.5 of a day, 0.125 of a day, right? So again, do you see that it is month is continuous? So days also have to be continuous. Okay, the next one, right? The city of Buenos Aires adds 6,000 tons of trash to its landfill every day. We would say the domain is days. We would say it's continuous because trash being dropped off at the landfill can occur at 0.5 days and 0.125 days. Okay. Next, during the Great Depression, stock market fell at 75%. The domain here is the Great Depression. Okay. The Great Depression is a singular event, and what happens as a result is the market price fell by 75%. We would consider this discrete because the Great Depression is a one-time event. You can not have 0.5 of a Great Depression or 0.125 of a Great Depression. Alright, let's go to the go part now. Either find or use the unit rate for each one of the equations below. The unit rate is referred to as the unit rate is one of that thing. Okay, this is the key idea. We're going to talk about this in a bit. Alright, let's look at this. Apples are on sale at the market at £4 for $2. What is the price for £1? You see it's £1 here. When they refer to one of something, they are looking for the unit rate. So here we have $2 over £4. If you put that in your calculator, you're going to get 0.50, right? 0.50 is what you're going to get in your calculator, right? If you plug this in your calculator right now, if you want to see, and your calculator is going to be 0.5. That is dollars. Again, it's any number, it's just over 1. And the unit for that was pounds. So for £1 you get 50 cents. Does that make sense? Okay, because at £2 you get what? $1. Then at £3 you get 1.50. Then at £4 you get what? 2. You see? Does that make sense? Good. All right. So that is how we find the unit rate. It's mostly a division. Okay. Next, 3 apples weighs about a pound. How much would 1 apple cost? Okay. So 1 pound, 3 apples. You want to find 1 apple. So 1 over 3 in your calculator should equal to 0.3333. Do that in your calculator. Again, it's divisible by 1, and that unit is just that bottom unit here of apples. So 1 apple costs 0.333 pounds. 1 dozen egg costs $1.98. How much does 1 egg cost? So again, $1.98 over 12 eggs. How, right? Do that in your calculator, you should get $0.165. That is over one egg. So one egg costs around 17 cents. 19. One dozen eggs cost $1.98. If the charge at the register for only one egg without tax, it is $11.88. How many dozens were purchased? A little bit weird. Here you have to cross multiply, right? You have $1.98 for one dozen egg. Your total price was $11.88, but you do not know how many dozen. You see, this is how many dozen. How many dozens? You don't know that. That's why I put the variable of x. When you set up two ratios comparing to each other, you can cross multiply. So x times 1.8 is 1.89x. On the right hand side, 1 dozen times 11.88 is just 11.88. Divide to get x alone. You should get x 11.89 divided by 1.98 is 6. So you would say x6 is your dozen eggs, because you see the unit here is dozen eggs, so the unit here is also going to be in dozen eggs. 20. Best Buy shoes have a back to school special. The total bill is for 4 pairs of shoes comes up to $69.24 before tax. What was the average price for each shoe? Right, where what they say by the average price per shoe is each shoe has the same value. Okay, that's why you can divide. So $69.24 divided by 4 pair of shoes, you should get in your calculator 17.34. That is equal to 1 pair of shoe. So you would say 1 pair of shoes costs $17.31. The next question, it says if you're purchasing 1 pair of shoes, again, 1 pair of shoes costs us $17.31. Here you're just solving for x. So 6x equals to 72. You want to divide 6 to both sides. You get x equals to 12. 23. 4x equals to 200. Divide 4 to both sides. You should get x equals to 50. 24. 3x equals to 50. Divide by 3 to both sides. You should get x equals to 50 over 3. 25. 12x is equal to 25.80. Divide 12 to both sides. You should get 2.15 in your calculator. 26. 1/2 x equals to 17.31. Multiply by 2 because you're trying to get rid of a divide by 2. Multiply by 2, you get 17.31 times 2. You get x equals to 34.62. 4x equals to 69.24. Divide 4 to both sides. You get 17.31 on the right hand side. That needs to be done in your calculator. There's no way you could do that off your head. 28. 12x equals to 198. Divide 12 to both sides. X equals to 16.5. 29. 1.98x equals to 11.89. Divide by 1.98 to both sides. You get x equals to 6. 30. 1/4 x equals to 2. Multiply 4 to both sides. You get 8. So 31 just asked you some of your problems in 22 to 38 can represent the work that you did 16 through 24. Write the numbers of the equation next to the story it represents. So these problems represent these scenarios. So you can just make that connection, okay? Alright, so there you go. Those are all your homework solutions for the 2.1 Ready, Set, Go.